make it, so I'm just going to start recording. Great. So for everybody who's joined us in the recording, what we're doing is we're putting our kits together and we're looking at the 4 elements we need, which is an input, output, processor, and power. And so what are we going to use as our input? And so what we have is we have 3 sensors. Okay, so let's see if you can identify. Let's have a look at what are the sensors that you're able to see in the bags. Anyone? Okay, great. Spencer, what do you have there?
I have a input that says 15 life on land. That's what it says. Okay,
so that is a soil moisture sensor. So you can open that bag, actually open it up, because that soil moisture sensor, you need to put it into the soil only up to the line.
Obviously.
Okay, yeah, that's great. Okay, so yes, so that is the soil moisture sensor, and yes, that relates to Sustainable Development Goal 15, which is life on land. Anybody else got another sensor? Okay, so I have. Okay, so what have you got there, Jim?
It says good health and well-being on it.
Okay, so that is, and so it's got a little cloud and a little weather symbol on the front. Okay, so that's
no, it's got a little tiny heart and a zigzag.
Okay,
right on the other side. Yeah, the cloud, right? The cloud with the sun, right?
Great.
I'm assuming it's a light sensor of some sort.
And what it is it's a weather sensor that's going to give us air temperature and relative humidity.
Okay.
And next week we're going to do an experiment that relates to comfort and well-being, because that's all around temperature and humidity. Okay, so that is our weather sensor with our little weather symbol. And then we have one that's got a light bulb.
Oh, yeah.
Okay. So there we go. So there's our light sensor. And this sensor is going to give us visible light, natural light, as well as ultraviolet UV index. Okay, so what we're going to do is we can put our kit together. And let me actually just go back to the slides. Okay, so if we want to put our kits together, what you'll see, those are our sensors. Okay, so what we have is output. Okay, so in this case, we've actually got 3 types of output. And we're going to be using 2 of them over the next few weeks. So what we have is, as output, we've got our little OLED screen. So it's an OLED screen. Okay, so have you all got that? This is by far the most delicate component that you have. So please be careful with it. If you may find that maybe the screen comes unstuck from the backboard. We used some super glue when we assembled them, and I've just found that, you know, sometimes it gets a little bit brittle, but it's fine. It'll still work. Just, you know, maybe you just glue it back, or maybe you just use some double-sided tape or something like that. But yes, that's your little OLED screen. And then what we have is we've got our core processor, which is this. So here's the front of our core, and it's got a little robot face here, so because that's our little robot brain. Okay, and what it has is it's got this really nice component on the back, which is an ESP32 unit. And so what it does is it has a relatively powerful CPU on it. It's got memory, it's got Wi-Fi, and it's got Bluetooth. So it's really good in terms of output, because what it'll do is it's going to convert the data from your sensors into a signal, and then it's going to give it as an output. either send it to the screen or otherwise send it via Wi-Fi to a dashboard, which we're going to look at a little bit later. And then you could also use your USB as an output, because what you could do is you could actually create a serial port, and you could output directly into a laptop or a computer. But we're not going to be using that in this workshop series, but we are going to use it when we start building our engineering models for our rocket launch. We're definitely going to use the serial port. But for now, we're only going to be using the USB for power. Okay, so yes, so here's our processor. So our processor, we're back to our chip with our robot on it. So yes, it's got 4 megabyte processing memory, Wi-Fi connectivity, Bluetooth. And what we've done is we preloaded it with Arduino code, so it's going to work straight out of the box for you. You can overwrite the code with your own code if you like, in MicroPython, in Java, C, C++. But if you also want to load the original code back on, you can, because what you'll do is we've got some tips on how to do that. So you could actually just, in a way, reset the factory settings. Okay, and then power, yes, we're going to be using our USB for power. So let's actually start assembling our kits. So you'll see here that with these connectors, there's a little tab between 2 and 3 there, and that is lined up with the little slot on the chip itself. So what I'd like you to do is I'd like you to line them up. And I think a good idea would be to connect the core and the light sensor. How about that? Connecting the core and the light sensor. So we refer to the one with the little symbol as the front. Okay. And if it's got anything like a sustainable development goal or something else, that's actually the back. So we always refer to the front where it's got the little symbol in the bottom right-hand corner. So I'd like you to line up the front of the core of your processor with the front of your light sensor and put those together.
Oh, they've got these connectors on the wrong thing.
Now, okay, so Jim, what I'd like you to do is I'd like you to have it facing
The other way? Right.
Yeah, just turn it by, if you wouldn't mind turning it by 90 degrees so that your symbols are both in the bottom right-hand corner.
Got it.
Okay. You've all got new connectors. They're going to be very stiff. Okay, so yeah, there you go. That's perfect. My connectors are very well worn. That's why I make it look so easy. But your connectors are still new, so it's going to take some pushing. Okay, so there you go. That's great. That's perfect. Okay, so that's our first row done. And you'll see.
So the positioning of the symbol tells us how they connect as well as, okay.
Yeah, absolutely. Absolutely. Sometimes you can put it at an angle. That is fine. You'll see later. When I connect the power, I can connect it 2 ways. But the most importantly is you shouldn't have the front and then the back together, because then it won't actually make the circuit. So there we have it. You'll see that there's 4 connection points for the sensors, the light and the weather sensor. They have 4 connection points, but this core, because this Wi-Fi hub takes up so much space, there isn't space for one on the top. So that's why I'm going to put it on the top row. Okay, great. Hi, Deborah.
So the guy in the upper right-hand corner.
Okay, so what I'd like you to do is I'd like you to now go to the next row if you wouldn't mind, and connect together. Let's connect together the screen and the blue shift chip. So what you'll see with this blue shift chip is that on the back there's a QR code. So that QR code takes you to the page where we've got all of the videos, all of the content, experiments and everything. So you can just scan that QR code on the back and it'll take you to that page. So what I've done is I've put my screen and my blue shift one together. And I'm going to put connectors on top, because now what I'm going to do is now I'm going to connect these like this. So what you do is you build rows and then you connect the rows. Okay.
Bottom here of the screen.
As soon as I put my connector on, the screen came loose.
Okay.
As you just said it might.
Yeah, I know it was that batch of super glue. I'm going back to the old one that I used to use.
Well, it also pushed the screen sideways when I put the connector on. So
You should be able to, you should be
look
able
right
to
there,
write at the.
you can see that the screen and the connector actually overlap slightly.
Okay.
So when I try to press it down, it's slightly at an angle. Not that that should matter.
I think
I can glue that down.
you can straighten it when you glue it. Yeah.
Yeah. Well, does it
Okay.
matter if the connector is not all the way on? Should I worry about the screen, or should I worry about the connector being fully connected? So
yeah, I think
when I put the screen back like it was, and I put the connector on, the connector knocks the screen sideways.
okay. Only slightly though. It should be able to fit.
Yep, only slightly. It's just a little bit off.
Okay. Jim, this is the front. The blue shift logo's on the front.
Right, I had it, yeah, like that.
Okay. Okay.
Yeah.
Cool.
Like that, right?
Yeah, that's great. Perfect.
Yeah. Still not,
Okay.
yeah, but that still knocks the screen sideways.
Okay. Well, I
So
think what you should
Push
do,
that
yeah.
down
Yeah,
unless
I
the
think.
screen's sitting sideways.
Okay, I think what you should do is when you glue it, make sure you already have a connector in.
Connector in and
So
just
that
glue it, and it'll be
you-
slightly catty corner.
No, it won't be. Just have a look, because it's flexible. That ribbon connector is a little bit flexible. It should be able to sit
It
right
does
next
not.
to you.
It does not. You can see, that's what it looks like when I press it down.
Okay,
it
okay,
on
Jim,
there?
okay. You know what I'm going to do? I'm going to send you a replacement. Okay, I'll send you a replacement. There must be
Okay.
something wrong with yours. Okay. If that's okay, maybe unless you want to open another one of your kits and use another screen.
I'm sure it'll work. It's not a.
Yeah,
I'm
it will.
sure
It'll
work. It's not a
definitely
problem.
work.
It's just cosmetic. So,
Yeah, it'll definitely work. Yeah, it'll
but
definitely work.
I'll try another one later and see if I have the same problem.
Excellent.
Yeah.
Great. And then what I'd like you to do is I'd like you to connect together I'd like you to connect together the USB. You can see it's got the little USB symbol in that bottom corner to your weather sensor. And then let's put that on the bottom row. Okay, so now we have now we have 6 chips. And what we have is with them like this in a rectangle, what we've got is we've got some redundancy. So if something goes wrong with one of these connectors, the power and the communication can still get through using another route. I could have put them all in one long stripe if I wanted to. I could have it in an L shape. And sometimes we do that. If we need to fit it into a model rocket or something like that, we'll put them all in one stripe. The rule is you want to be able to see the symbol on the bottom right-hand corner. Okay. Okay, so there is a reason why I've done this in exactly the order that I did it. There you go. Absolutely. Spencer, that's great. Wonderful. So there's a reason why I've done it like this, is that I find, depending on what power bank I use, what USB power bank I use, sometimes I find that this core can get a little bit warm. It's not a problem, but the thing is, if it gets warm, I want it as far away as possible from my weather sensor. Because this is the sensor that's measuring temperature for me. So I want to have this as far away from my temperature sensor so that it doesn't interfere. Okay. However, there are also times when I find that my USB gets warm, and then I swap around the light sensor and the weather sensor. Okay, so that is just something just to take note of. You just want to make sure that when you're collecting data, that you don't have something else in the environment that's interfering with it. So we're ready to add power, and so let's see what happens when we add power. Wow. Okay. So when it first turns on, what it does is it shows you the weather sensor. So it's got a little thermometer with temperature, and then it's got a drop with relative humidity, which is air humidity. When it starts, it'll give you 0, because what's happening is it's still loading the code. So you just need to give it like 10 seconds or whatever for it to start showing data. Okay. Spencer, have you been able to connect yours to power?
Yes, but it's obviously off to the side of my computer because I do not have a second.
That's okay. That's all right.
It's currently reading me 30.2 for the temperature. The light, or there's an umbrella symbol, and then after that, it's the second mark is ticked on the entire thing. It's 5 boxes.
Yep.
The second one is highlighted, and then after that, there's a big raindrop symbol that reads 20.3% RH.
Okay.
Oh, we got the same things, but our temperatures and relative humidity.
Exactly.
Yes. So the temperatures in centigrade. And the reason for that is that everything we do in space is metric. Exactly. So it's going to take a little bit of getting used to. And then the relative humidity, yes, is a percentage. So Spencer, the data you gave us is quite interesting, because that's actually quite a high temperature. Do you think it's reading the temperature? Is it reading some heat from your laptop, do you think?
Definitely, because my computer has like 14 Chrome tabs open, so I definitely think that this thing is
Okay, because what you said, it was 30 something, which is like really
31.2 now.
31 is like uncomfortably warm. That's like, well,
exactly.
That's like definitely over 100. Okay.
We got 26.5% relative humidity, so we're all right.
Yeah. Okay. And so, yeah, and that's also fairly dry, 26%. So yeah, I think it's some air that's coming from your fan or something like that.
Exactly.
Absolutely.
That's
Ruthann,
19.4.
yeah,
So-
Ruthann, have you been able to put yours together?
Yes, I have 23.1 for my temperature,
Great.
and the humidity is 25.
Okay.
And I have a big raindrop.
Yes.
And an umbrella, I think, is what it looks like.
Yeah.
I don't know what that is. Is that an umbrella?
Yeah, it's meant to be an umbrella. It's just meant to
Okay.
give us an idea of, that's our weather sensor.
And
So
the
if-
I'm sorry, the little squares at the top, there's the second one's all filled in yellow.
Great.
Little
Great.
line of squares. Okay.
Okay, so now, Cassie, how are you doing? How's your team doing?
That's probably.
Nathan, Allie, to the office, please. Nathan.
Okay.
That's normal.
Nathan's in trouble.
He's still
Okay.
on mute, so.
Yeah, and Niles, have you been able to put yours together?
Yes, and ours is 25 degrees Celsius and 16.7 RH. So very dry.
Okay. Okay, that's great. So now if we want to move on, so what you do is you scroll over here. These are touch sensitive pads. So you just touch that little arrow there on the top and it'll take you to the next screen.
Yeah.
Okay. Okay, so mine says soil moisture with a cross through it. And that's because I haven't connected my soil moisture sensor.
Yeah, that makes sense. And obviously that's what this is.
Okay, yeah, absolutely. Okay, so I'm just going to scroll on a little bit more and then I get my, okay.
There's a nice.
Has anyone got the light sensor showing?
I've got a light sensor reading 760 lux,
Okay.
and
And
my UV is pretty low,
should
0.04.
be, okay. So that's very interesting. That's very interesting, Jim, because that means that there is actually some UV in that room. So you've got fluorescent lights. Okay,
We have
so that's
fluorescent lights, and of course, it's got a little light emitting diode, and it's near my screen. So any of those could conceivably be putting out a little bit of a UV.
yeah, absolutely, absolutely. So yes, so the lux reading is a measure of your light intensity. When it's in the full sun, it'll be in the thousands. So yeah, it's actually great fun, to get the torch on a smartphone and actually shine it, and then you can see it just goes off the charts. Okay, so if you scroll on one more, you'll get to that soil moisture, and then the next screen will take you to where you'll have a username and a password. Okay, so the username is at the top, and then where the little key is the password. So what I'm going to do is I'm going to start sharing my screen again so that we can see where that is. Okay, so we've put our kit together. So you see, if you have a look at the screen quickly, what I did is, because I wanted to add my soil moisture sensor here, what I did is I took my USB and I connected it at right angles there to the core. So you can do that. You can actually connect it at right angles when you connect the soil moisture sensor. Okay, so here we go. So what we've got is where it says SDG, because this is what we refer to as our SDG code for the Sustainable Development Goals. So it'll give you a username, and then it'll give you a password. So what you do is, at this point, you use your smartphone to connect it to the Wi-Fi. I'm concerned about trying to do it now during this workshop, because if you are in a classroom environment where you've got perhaps a 3-level Wi-Fi security, etc., it may not actually work. So what I'd rather do is I'd rather have you watch the getting started video. It's a very quick video to go through that, because what I'd actually prefer us to do is to run our first experiment so that we can get to know our kids and we can get to understand our kids. But the video, it has these exact slides, and it's going to take you through exactly how to do it. And so, yeah, so what I'd like us to do is I'd like us to actually start running an experiment. So this is the experiment that I'd like you to perform with your kids. So if what you can do is you can keep scrolling through. If you select this one with the checkbox, okay, that little checkbox, if you press on that, what it'll do is it'll just scroll automatically. So it'll just keep scrolling, which is quite nice. So you can just look at it and you can just read the sentences as you like them. And that's also why we have this progress bar at the top with those little yellow squares. Okay, so you can see which one you're on. So this is the experiment I'd like you to conduct. What we'll do is, if it's okay, let's conduct it over the next few days so that we've done it before we get together next week. So here it is. I'd like you to determine whether there's a relationship between natural light and air temperature. Okay, so who can tell me, if I'm looking for a relationship between natural light and air temperature, which sensors am I going to use and what data am I looking for?
How do I get that?
Spencer, how about you? How about the two of you?
What was the things that we're looking for specifically?
Okay, so if you want to determine whether there's a relationship between natural light intensity and air temperature, what data would you collect?
So that's the temperature.
You would probably want to collect the amount of lumens in the air, like in your area, as well as the temperature outside, because
right up here.
you'll notice through like a function, if you were to use it mathematically, there'd be the more lumens usually the hotter it gets. The less lumens, the less stronger the lumens are. Then after that, the less kind of the temperature usually, but obviously there's certain circumstances that can cause problems.
Of course.
Exactly.
Absolutely. So the important word that I used was natural light. Okay, so in other words, what we're looking at is you're looking at sunlight intensity.
UV.
Because you're absolutely right. The brightness of an artificial light could bear absolutely no relationship to the temperature in the room, the air surrounding it, okay? So yes, we're looking at a relationship between natural light, so it'll be outdoors, it'll be sunlight, and light intensity, so the lux level, the brighter the light, the higher the lux level. Yeah, when you refer to lumens is very much what you would use if you had an artificial light.
Yeah, exactly.
It's rated in lumens, but when we measure light
outside, it's a lot different than it is.
Yeah, it's just
lumens.
Yeah, we refer to it as lux. Yeah, we refer the one is what you read lux, whereas you emit lumens.
Okay,
so
perfect.
Like, depending which way it's going, if you know what I mean. Okay.
Yeah, exactly.
So you want to read the lux level of the natural light. And then also you want to compare it to the temperature. Okay, so you'll be reading the one from the light sensor, the light from the light sensor, and the temperature from the weather sensor. Okay.
Exactly.
Okay. So Right, and then there's another way to determine whether it's natural light, and that is that if you're outside in the sunshine, you should have a UV index of at least 1. So you'll be able to see that if you're in actual bright sunlight, you'll see that your UV index is over 1. And that is why I mentioned it, you know, with Jim being indoors, that he's got some UV there, because it's actually very unusual for there to be.
I am right next to a window.
Oh, you are? Well, then maybe
Yeah,
maybe
Right
you're
there.
actually
So
getting reflected.
I may be getting a
could be-
little.
Yeah, you could be getting reflected UV light. Absolutely, absolutely. So, so before we embark on it, I just want to go through a little bit of research methodology or whatever. Okay, before we conduct our experiments. So it's all about data collection, but before we collect our data, we also need to have some planning, right? So the first thing we've got to do is, what is our question? So our question is there a relationship between natural light intensity and air temperature? Okay. We've already gone through what data sets you would like to collect. So it's going to be light intensity, which is lux, and it'll be temperature, air temperature. And then how will we collect our data? Okay, are there any suggestions there on how we would collect the data?
Outside in different levels of shade and brightness?
Absolutely, certainly you would. The thing is that what it is that your sensors are giving you, your screen actually is giving you the data that's been collected from the sensors. So since I'm not using a dashboard or anything like that, what I would do is that I would draw up a table first. And I would say, I'm going to pick, let's say, for example, 5 or 6 places where I'm going to collect my data. And then I would have columns for the location, another column for the lux level, and another one for temperature, and maybe an additional column for UV index. You never know, it could actually be useful a little bit later. And then how can we verify that the data is correct? So one of the things that we can do in terms of verifying that it's correct is, we know we're in natural light if we do have just something, a UV index of around 1 or more. But also the thing is, what we need to do is we also need to be a little bit critical, as we were, as Spencer was, in terms of the temperature level that he was getting on his weather sensor. He knew, okay, well, I've got a lot of tabs open and my computer is working really hard. So I'm not going to have an accurate level here. So we need to also be able to verify for ourselves, are we being realistic when we're taking this reading, or are we just simply writing it down? So what we need to do as well is we need to plan. Planning costs nothing. And the better we plan, the fewer mistakes we make. So what we need to do is we need to plan time, materials, resources, and team members. These experiments are really great if you're working in a team, because you're going to have a scribe, somebody who's writing down the data, somebody else who is actually reading the data, perhaps somebody who's going and identifying the next spot where the data collection is going to take place, etc. So what you can do is you can have different roles in your team, and we have different tasks that everybody performs, so that you're able to do it all together. So the resources you'll have is you'll need to have your kit, and you'll also need to have some kind of independent power bank, because we've realized that if you plug it into the laptop, you may actually have some interference in terms of your data readings from a heat perspective. Okay, so if we actually take this and we say, right, so our question is there a relationship between natural light and temperature? We know what data we're going to collect. And from a planning perspective, yes, I would really recommend at least 6 locations. It's also nice if you, once you have your data, is actually to draw a graph. And on one axis, you have, on the one axis, you have temperature or light intensity. In fact, because of the way the question is posed, we're looking to see if temperature is a function of natural light. So therefore, temperature should be on the x-axis and light should be on the y-axis. Am I correct there? Who's a maths teacher? I don't want to mess this one up.
That's right.
Okay, so y equals f of x. Y is a function of x. So we
Yes.
want to see, does y change when x changes? Okay, so, right, okay. So therefore, temperature's on the x-axis and lux is on the y-axis. And then what you can do is you can plot it.
Other way around. Natural light, the lux will be on the x-axis, the independent variable, and the
Very
temperature will be the dependent variable on the y-axis.
Okay, you're absolutely right. Okay, yes. Is temperature a function of light? So yes, so temperature is on the y-axis. You're very correct. Thank you, Jim. Thank you. And then the x-axis is the light intensity. And so what you'll do is you'll plot them and you should see that there's a trend. You should notice some kind of a trend. And what I would recommend is that you have very different environments. You have full sun, maybe on the tarmac or on concrete or paving or something like that, versus sunlight maybe on a lawn or near some vegetation, under the shade of a tree, under the shade of a solid overhang, etc. And here you'll also see that it's very interesting what happens with the UV index. Is that shade cloth doesn't protect us very much from UV. It may create shade, like an umbrella may create shade, but it doesn't really protect us against ultraviolet radiation, whereas a solid surface does, etc. And you'll also find that there's a difference if there's vegetation around. I'm not going to say anything about that. Let's discuss it next week when we discuss our experiments. And then, yeah, to see what relationship do we have there. Some tips for you. When you're measuring your light, it's best to have your light sensor at right angles to your light source, okay? Because it makes a massive difference. The angle of the sensor board to the light's rays makes a massive difference, because it's, in a way, it's all about vectors, okay? So make sure that you're collecting your data, especially your light data, because it's directional at right angles. Another thing is give it probably a minute to acclimatize. So if you have a very, very, very close look at this little weather sensor, you'll see some of you, well, we've got 2 different weather sensors because we made 2 boards, but they perform exactly the same task. Some of you may have like a little stainless steel cap over the sensor. And so what it is that the air actually needs to get under that so that we can actually measure the temperature. So please just leave it for about a minute before you take the reading. It needs to acclimatize to its environment so that you know that you're getting an accurate reading. So that's just some tips. If you wanted to stop scrolling, you just click this little X. And what it'll do is it'll stop scrolling. So if you say, wow, please just keep still, I just want to take my light reading, you can click on the little X. And if you wanted to start scrolling again automatically, you do the little circle with the check sign, the little tick, and to scroll backwards and forwards, your backwards and forwards little buttons over there. So yeah, that's it. And let's have a chat. Let's have some questions. Let's now have a discussion about what we've been doing. I think it seems as if we've lost Cassie's students.
Yeah, she sent a message in chat.
Yeah, they
Okay,
haven't
we have to.
closed. Cool.
Oh,
Yeah.
okay. Okay, that's fine. That's cool.
This has been great, Judy. These are awesome little devices.
They are, aren't they? They
Yeah, it's
are a lot of
amazing.
fun.
Yeah, I'm very impressed with these, but I have noticed that my temperature sensor has dropped almost 2 full degrees since I first plugged it in to now.
Yeah, it's
it
acclimatized. Yeah,
Seems finally to have stabilized.
yeah, yeah,
For
absolutely.
a while there, every time I was looking at it, it was a little lower. I'm like, oh, good. I didn't think it was that warm in here.
Yeah, so it does. It really, it does. It needs to acclimatize. It needs some time to acclimatize. Spencer, yes, absolutely. Please, yes, the two of you do need to go. That's absolutely great. We'll see you next week. We'll see you around. Thanks so much for joining us and taking the time out.
I'm gonna
Thanks.
have to go
Thank
too.
you. Okay,
I'm gonna have to go
wonderful.
too.
Ruth Ann,
Thank you very